concerns. What are we in the middle of right now?
Math.
We are. What were we talking about when we last were together?
Math.
Yes, a little less general.
Be more
Actually,
specific,
statistics,
please.
more than math, actually.
Using the little
Statistics.
sheet.
We were using, oh, speaking of which, does anybody need the data sheet? I've got extra copies, which means that some people don't have them yet. Go ahead and hand those around if you don't mind, John.
The big if.
The big if. Oh,
The big if.
very good, Joanne. The big if rule. The big if rule. What was the big if rule about? Who remembers the big if? Riley, help me out.
Your data is approximately bell-shaped.
Okay, so it was if you have data that's roughly bell-shaped, then you get certain percentages of data that are within what? Ooh, Andrea, standard deviations of what?
Average bell curve?
Of average. Okay, so what we were looking at last time, it took us a long time to kind of slug through that, and that made me happy, was the idea that if you have bell-shaped data, which we did with that weight loss data right there from that study, you can predict roughly what percentage of your data is going to be a set distance from average. So what we were looking at as a larger picture was how to tie the idea of measures of center to measures of variance.
Could you repeat that big if rule again?
Please, actually, I'm going to have you guys repeat it. Repeat the big if rule again. And remember, too, Davidson, this stuff's all recorded and waiting for you. But I want to say it right now again, though. Repeat the big if rule. Joanne, if you don't mind.
If your data is approximately bell-shaped, roughly 68% of the data will lie within the average plus or minus the standard deviation.
That was a damn good job. It's right. That was beautiful. So that's within one standard deviation. How about
B.
two?
With a highlight on this, that roughly 95% of the data will lie within the average plus or minus 2 standard deviations.
How about three?
Roughly 100, but more like 99.7% of the data will fall within average plus or minus 3 of the standard deviations.
Oh, perfectly said.
And this is the 68, 95, 90% method.
And thank you. That was absolutely perfectly said. Golf clap. I realized I was going to make another quiz for you guys this week on this, and then I realized I already had a video prepared with an explanation linked into the Variation Extra Resources. So if you go into the Variation Extra Resources, there's a video that pops up about 5 minutes long that actually shows the construction, if you will, of what Joanne just mentioned. So if you're interested, again, in more examples, there's a video that does hundreds of thousands of them for you all at once in Excel. How about within a half a standard deviation, Joanne? Did we talk about that at all?
No.
Or 2/3 of a standard deviation, or 1.5? Good! We'll have a quiz on that next week.
Well,
Should you choose to accept that challenge, which you don't have to, of course.
2/3 be the 68%?
That's one. But so Joanne, the reason I bring this up, so you got a bell curve, if you have a bell curve, big if. And you just told me beautifully that within one standard deviation is 68%. My question is, what if you only go out 2/3 of a standard deviation? What area is that? It's less than 68, right?
Oh.
The question is, how much is it? And what we'll do is we'll have a quiz to explore, if you want to. You don't have to choose to do this quiz. We'll have a quiz to explore other standard deviations besides 1, 2, and 3. Because they are useful from time to time, especially with something we're going to start talking about today at the halfway point of our class.
Would that be like
So,
22.6?
we'll get to that. We'll get to that. That's what the quiz is going to be. It's going to be exploring the other standard. You don't have to go out a whole number of them. You can go out 1/10 of a standard deviation. You can go out 8 standard deviations. You can go out 1/2 or 1/3 or an 1/8. I mean, there's all kinds of reasons as to why you would do that. You don't have to go out whole numbers. It's just the 68. It's funny, if you Google the 68, 95, 99 rule, you'll get hundreds of thousands of hits. If you Google the 50, 68, 99.5 rule, you'll get 0 hits. And I always wondered about that. I'm like, wow, we're making students memorize only 3. And sometimes, and Joanne mentioned the highlight on the 95, that is the one that you see the most in research. But it's not always the most important one. Depends on what confidence you need. Depends on how you want to be wrong, which is all we're talking about during this class. And Taryn's like, I don't want to be wrong. Well, good. But the best you can do statistically is minimize the chance of being wrong. You can't eliminate it, you can minimize it. And sometimes that, well, we're getting ahead of ourselves a little bit here. Fair? Questions you have right now before we continue? I do have an in-class quiz I want to do with you guys next. But I want to make sure that you guys have your questions answered before we begin this. Cool? Okay. So, I love where we are right now.